Alright, number 139 word break. Given a string S and a dictionary of strings word dict, return true if S can be segmented into a space separated sequence of one or more dictionary words. The same word may be reused multiple times in the segmentation. Alright, so I gave this one a go yesterday and had absolutely no luck with it, and spent a few hours going through this type of question and have come to the conclusion that this is definitely a dynamic programming question. One of the things to look out for with dynamic programming questions is that they will very often have something to do with strings and segmentation. Because we can, like, yeah, it just is. And I found this question very challenging, but have explored the answer and I'm hopefully going to be able to explore it here. So let me grab our first example. So the way that this is going to work is we are going to have to create a array full of falses, which is of length n plus 1. And these are going to represent the end index of each subword that we're going to try. So the reason we do the plus 1 here is there is going to be a base case of an empty string, which we will have to set this to true. That's just for if we were to get an empty string and to build our solution off of, which is how dynamic programming works. So what we are going to do is we are going to loop over this, and then we are going to loop over each letter before this. Like, let me explain that better. So we're going to loop over this with a for I, and this I here is going to represent the end of the word. So we have to try all the different subwords in here to try and see if we can get these made up. So when I hits here, we're going to have another for loop here for J, which is going to be here, and we're going to see, wow, leet. Yeah, that's a word that is in word dict, and then we can set our fifth index, which will just be here, as true, because we know this is also true. So hopefully that'll make more sense when I code it up, but we're going to use a J loop here to mark the start of our subwords, and then we're going to use an I loop here to mark the end of our words. So I'm going to give this a go. So we need to start with the length of our string. So n equals len of s. Then we need a false array. We're going to call it DP because this is a bit of dynamic programming. Alright, we'll start our DP list with false, and then we will multiply it by a length of n plus 1, which will give us our n plus 1 false array. Then we need to do our first value as true, because we have to remember that the case of an empty string exists, and in that case we'll have to return true. Then we go for I in range 1 to n plus 1. I think I'm just going to quickly print I to make sure that's right. Because it's exclusive up here. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Exactly what I wanted. Then we're going to have a 4j in range I. This will represent the start of our word. This will represent the end of the word. So then we need to do if dpj equals true and s j to I is in word dict. We then set dp I equals true. And then we just continue the loop. dpi equals true. Yep, cool. That's done. We go to the next I. We go to the next j. Then I think we just return dp -1. Beats 8%. That's not great. I have the solution near me. Apparently we can break out here, which makes sense because we've already set our DPI to true, so we can just break back to I and go to the next one. So I'm going to give this a go. Hopefully this speeds it up. This will get rid of a lot of redundant calculations once we find our first letter. Yep, there we go. Beat 60%. I'd love to see some of the faster solutions that are using the same idea and not caching. So false for I in range n -1 -1 for word indict. Dot starts with word. Alright. Backtracking with a cache. Honestly, I'm pretty happy with this solution. So the reason we do this is because this makes sure that our start is equal to true, and it would not have been included in the previous word just because this is exclusive. So if that's true, we know that it's can be segmented, I guess, and this break here is because we don't need to know how many words can fit into it. We just need to know if it can. Then we have our index here, so the J is J to I excluded is in word dict. Then we set our I value to true, and we know that the I won't be included in the previous words. That's why we're not getting like weird overlaps. And yeah, definitely I think might be more than a medium, but maybe that's just because I don't know dynamic programming very well. Hopefully I'll try a few more and still be able to get them because yeah.